Welcome learners. In this video lecture, we are going to discuss characteristics of frequency distribution or data. These characteristics are nothing but the qualities of data. Every data must possess some qualities. To describe statistics, we use that characteristics. After completion of this lecture, you are going to learn about the characteristics of data, descriptive statistics. The first characteristic, central tendency. Next one is dispersion or variation or scatteredness of frequency distribution. These moments are peculiarities of a frequency distribution. Mainly there are four characteristics only: concentration or location, variation, and the skewness. Skewness of a frequency distribution. It is also one characteristic of frequency distribution. And the last characteristic is kurtosis. Nothing but the peakedness of the frequency distribution. Okay. After collecting the data, we need to classify it and tabulate it. After tabulating, only we can we can calculate different statistical measures from that data. We represent the data in the form of diagrams and graphs also. In the graph, we draw frequency curve. Now, the next task is to describe the data with some numerical measures. To describe a frequency distribution, there are four characteristics. First one is central tendency, nothing but location, dispersion, also called variation, skewness, nothing but lack of symmetry. There is positive and negative skewness of frequency curves, and kurtosis or peakedness of the frequency curve. There are different measures to measure these characteristics. I already told you in the syllabus discussion, the unit 1 and unit 2 you have already studied in previous sections, previous classes. From 9th class onwards, you are studying the statistics, measures of central tendency, mean, median, mode, geometric mean, harmonic mean, and dispersion also you have studied. Up to intermediate, you already studied the probability distribution also. Probability, measures of probability also. Here, the same concepts, measures of central tendency, measures of dispersion are the same concepts, but you are going to study them detailedly, in depth, and the utility of those measures you are learning here. The first characteristic of a frequency distribution is the central tendency. It is nothing but the concentration of items or observations towards the central part of the frequency distribution. This is the definition of central tendency. As it locates a distribution at some value or at a single value of the variable, it is called a measure of location. Measures which measures the central tendency are called measures of central tendency or averages. There are five averages are in common use. Arithmetic mean or simply mean, nothing but the ratio of sum of observations and number of observations. Arithmetic mean is given by sum of observations divided by total number of observations. Next measure is to measure concentration. Median. I noted the Q2, D5, P50. What is this? There are three quartiles for Q1, Q2, Q3, which divides the data into four parts. It is a median. It is median. Q2, it is a measure which divides the total data into two parts only. It is the middle value of the middle item when arranged in ascending or descending order. There are 9 deciles which divides the data. There are 9 divides which divides the entire data into 10 parts. This Q2 is nothing but D5. It is the middle of the series. Also, there are 99 percentiles which divides the data into 100 parts. So, median is nothing but Q2 or D5 or P50. It is the middle value in the data. Mode. It is the value which occurs most frequently in the data. It is a measure of central tendency. Also, the fourth measure is geometric mean, GM. It is nth root of the product of the n items. Difficult to understand, but you know the formula. So, we also going to discuss the formulas in detail with their merits and demerits. The last measure of central tendency is harmonic mean, the reciprocal of the arithmetic mean of the reciprocals of the given data. Okay, if a only single measure which is sufficient to measure the central tendency, we need not go for another measures. There are 5 measures. These measures are used to measure central tendency. I have given the total table of all these 5 measures, calculation, formulas. There are 3 types of data. This is raw data. This is discrete frequency data. This is continuous data. In case of raw data, this is the formula to calculate mean. Sum of observations by number of observations. In discrete data, the frequency enters sigma Fi by sigma Fi or sigma Fx by n. Here sigma F total frequency is called denoted as capital N. Here x is the value of the variable. And in continuous data, we have data class interval and frequency. We find mid value of the class intervals. This x is the mid value of classes. This a plus sigma fd by n into c is the deviation method to calculate arithmetic mean. Here d is equal to x minus a by c. A is the assumed value, any arbitrary value. C is the class interval. Median is the middle value. It is in we first calculate cumulative frequency for discrete data. Median is the value of the variable just greater than n by 2 cumulative frequency value. Similarly, in case of continuous data, it is given by L plus n by 2 minus m by f into c. Here L is the lower limit of the median class, n is total frequency, m is cumulative frequency up to median class, f is the frequency of median class, and c is the class interval of median class. Next, mode is the frequently occurred value. In case of discrete data, a value with highest frequency is mode, and in continuous data L plus f minus f1 by 2f minus f1 minus f2 into c. Here L is the lower limit of model class. Model class is the class with highest frequency. F is the frequency of model class. F1 is the frequency just before or above the model class. F2 is the frequency just below or before after the model class. Next, the formula for geometric mean is it is nth root of n observations, product of n observations, nth root. Similarly, generally we take logarithm and we transform the product into addition. Antilog of sigma log x by n gives us the geometric mean. Here also antilog of sigma f into log x by n, antilog of sigma f into log x by n. Here x is the value of the variable, x is the mid value of the variable. Generally, the harmonic mean is given by n by sigma 1 by x. Here, this sigma 1 by x by n. This multiplies the denominator. Here, n by sigma f by x. Here, x is the value of the variable. Here, x is the mid value of the class limit. Okay. If one measures of central tendency describes the data, what is the need for another method? The measures of central tendency describes one aspect of the data, while central position. This measure alone is not enough to describe the data fully. Using this measure alone, we will not be able to make meaningful comparisons or draw valid inferences, valid conclusions. Let us discuss in detail. Consider the data in the following three series. There are three series. The first series, look here, 70, 70, 70. 10 observations are there. All observations are 70. Next is, look here, gradually increasing. This is the series 2, 66 to 74. Minimum is 66 here, maximum is 74 here. Let us look at here. The third series, minimum value is 1, maximum value is 120, gradually increasing. Definitely, these three series are different, not same, but we calculate mean for the three series. Here, sigma x is 700 for all the three series. N is 10. Sigma x by n is 700 by 10. The 70 is the mean for all the three series. But we can find these three are not same. Here the minimum is 1, maximum is 120, minimum is 66, maximum is 74. These all observations are near to the central value. 70 is the central value, 70 is the central value, location value. All observations are concentrated in 70 only, but here the difference is 69. Here also difference is 50 from central point to 120. So if we did not know the data, all three series having equal mean. So the mean is not describing the data completely. It should be supported and supplemented by some other measures, nothing but measures of dispersion. Definition of measures of dispersion. A measure of dispersion or variation or scattered or spread is to be describe the extent of scattering of the items around a measure of central tendency. A measure of dispersion is defined as an absolute or relative measure of differences of the values of the various items from a measure of central tendency of these items. The difference between the value of an item and a measure of central tendency is called as deviation, xi minus x bar. An average of the deviations of the values of various items from a measure of central tendency is called as a measure of dispersion. We can define dispersion as this: difference between each and every value and mean value. It measures the scatteredness. It measures the variation among items from central part of the data. Measures like mean, median and mode are referred as averages of first order. These are the measures of central tendency or averages of first order. Measures of dispersion, those derived from the average of first order. To calculate measures of dispersion, we are using averages of first order. So the measures of dispersion are averages of second order. Next is various measures of dispersion. There are four measures. You all know range. It is the difference between maximum value and minimum value of the given series of the data. Quartile deviation, also called semi-interquartile range, half of the range between Q3 and Q1. Symbolically, it is given by quartile deviation is Q3 minus Q1 by 2. Here Q3 is the third quartile, Q1 is the first quartile. The average of the difference between third quartile and first quartile is known as quartile deviation. It is semi-interquartile range. But the above two measures are suffering from a drawback, that is, they depend only on two values. Range is depending on maximum and minimum value. Just by using two values, we can get range. Here also, just by using Q3 and Q1, we can get the quartile deviation. Not involving all observations in the data, it become inferior to other measures. Next measure of dispersion is mean deviation. We already defined the deviation. It is arithmetic mean of the absolute deviations of the various items from a measure of central tendency. The deviation from which the mean deviation is calculated may be mean or median or mode. If we calculate mean deviation from mean, it is called mean deviation from mean, mean deviation from median, mean deviation from mode. We can calculate mean deviation from an arbitrary value also. We are taking absolute deviations because, look here, this is a property of mean. The sum of deviations taken from their arithmetic mean is 0. Sigma xi minus x bar is equal to 0. To get rid of this drawback only, we are taking absolute deviations, which is mathematically illogical. By taking absolute deviations, we are ignoring the sign. To overcome the drawback, the last measure, standard deviation, which is an ideal measure of dispersion, is root mean square deviation. The definition of standard deviation is square root of the arithmetic mean of the squared deviations of the various items from arithmetic mean. Symbolically, it is denoted by sigma root of sigma xi minus x bar whole square by n. These are also deviations, but these deviations are squared. While taking absolute deviations, we are squaring them and we are rooting them. Okay, by using these four measures, we can find measures of dispersion. Note that these are second order averages. Next one is introduction of symmetry. Look here, what is the need for symmetry? What is the need for going another measure of describing the data? Here, mean and standard deviation. Mean is the central value, standard deviation is the extent of scatteredness of two important aspects of distribution of a data. They do not describe all the aspects of the data. Let us look at one example. Look here, these three groups. Here, x is the variable, 2.5, 7.5, 12.5, 17.5, 22.5, 27.5. Let us look at the group 1. Here, they are gradually increasing and gradually decreasing. If it is the mean, increasing up to mean and decreased from mean. This type of data is called symmetric data. Look here, the data is scattered here. This is the mode for the data. Highest frequency here. Highest frequency is in the fourth observation, whereas highest frequency is in the second observation. In the beginning itself, 7.5 is the highest here, 17.5 is the highest here. Okay, the mean and standard deviation are same for all these three groups. Mean is same, standard deviation also same. Mean is 15 for the all the three groups. You take this as an exercise or homework. Calculate mean variance for the data by taking x as 2.5, 7.5, group 1, x and group 1 separately, x and group 2 separately, x and group 3 separately. Mean and variance are same for these three groups, but there is difference between these three groups. This is symmetric data. Symmetric data is gradually increasing and gradually decreasing. There are some characteristics of symmetric data. A distribution is said to be skewed if mean, median, mode fall at the same points. Okay, this is skewed. If mean, median, mode are same, mean is equal to median is equal to mode, then that type of data is called symmetric data. For a symmetric distribution, mean, median, mode coincide. That means mean is equal to median is equal to mode. Quantities are equidistant from median. That is Q2, Q3 minus Q2 is equal to Q2 minus Q1. The curve drawn to be to the given data is symmetrical curve or bell-shaped curve. If these three characteristics are not satisfied, then the distribution is said to be a skewed one. For a skewed distribution, mean, median, mode do not coincide. That is, mean not equal to median is not equal to mode. Quartiles are not equidistant from median. Q3 minus Q2 is not equal to Q2 minus Q1. The curve drawn to the data is not symmetrical and bell-shaped. Based on these characteristics, Carl Pearson suggested some formula to measure skewness. Okay. In our example, we have, look here, this is symmetric curve, and this is the mode is here negatively skewed curve, and group 3 is positively skewed curve. I will explain here. Look here. For mean, median, mode coincide, the shape is perfectly bell-shaped. This is symmetrical curve. Whereas in the third group 3, mode is here, 90 is in the beginning, and median is in the middle, mode is, mean is here. Here mode is less than mean. If mode is less than mean, that type of frequency distribution is called positively skewed frequency distribution. Mean, median, mode coincide, symmetrical distribution, zero skewness. Whereas in the second example, 90 is here, 90 is at the end. So mode is here. If mode is greater than mean, then that type of frequency distribution is called negatively skewed distribution, and the Skewness is negatively skewed distribution. Okay. If skewness is said to be positive if the curve is stretched right. This curve is stretched right. If it is stretched left, then that type of curve is called negatively skewed. Mean median mode coincide, it is symmetrical distribution. So this is another characteristic of frequency distribution, that is skewness. Skewness is lack of symmetry. There are two types of skewness. One is positive skew and another is negative skew. There are three measures to measure the skewness. They are Karl Pearson coefficient of skewness based on mean, median and standard mean mode and standard deviation, denoted by B.Sc, mean minus mode by standard deviation. The range of Karl Pearson coefficient of skewness is -3 to +3. Sometimes mode is ill-defined. In that situations, mode is equal to 3 median minus 2 mean. By using this formula, the Karl Pearson coefficient of skewness is given by 3 into mean minus median divided by standard deviation. Similarly, there is another measure to measure the symmetry. Bowley suggested this measure based on first, second and third quartiles. This is nothing but Q3 plus Q1 minus 2Q2 by Q3 minus Q1. The range of Bowley's coefficient of skewness is -1 to +1. This moments measure we will see later. And let us look at the fourth characteristic, last characteristic, kurtosis. Two or more distributions may symmetrical or yet different from each other in the extent of concentration of items close to the measure of central tendency. Let us look at this example. Here 10, 30, 60, 60. This is nothing but symmetrical distribution. Look here. This is 5, 15, 80, 80, 15, 5. More values concentrated between 2.5, 12.5 to 17.5. Whereas in the group 3, these are spread throughout the data. This is symmetrical. This is concentrated in the middle. This is spread throughout the data. Okay. Group 2 shows higher concentration of items closer to the mean values. If 60 is the mean, it is closer to the mean values. That is, the frequencies are higher in the middle. Whereas in group 3, the frequencies are more or less evenly distributed in all the classes. That is, the frequencies are less concentrated around mean. Oh, evenly distributed throughout the data. Look here. For a first group, this is the curve. That is the normal curve. In terms of kurtosis, it is mesokurtic curve. Kurtosis measures, it is a characteristic which measures the peakedness. The concentration of observations in the middle part are spread over the data. It is peaked. This curve, peaked curve is group 2 example. Group 3 example is negative skewness spread over the year, spread over the data. The positive skewness is nothing but leptokurtic curve, and this is normal curve, mesokurtic, and negative kurtosis is less than normal. Greater than normal is positive. Less than normal is negative. This is called platykurtic curve. There are single measure to measure the kurtosis, moments measure. We will discuss different moments and different measures of moments, beta 1, beta 2, gamma 1 and gamma 2 coefficients in the next lecture. Here I am sharing this document to you. The concepts, all the concepts discussed in this lesson are there in the material. Look here, this is the measures of central tendency. You can find the characteristics of questionnaire and schedule also. You will get 5 marks question in this questionnaire and schedule. This is measures of central tendency. We all know it is rigidly defined. It should be easy to calculate based on all observations. Should not be affected by extreme observations. This is the formula. One example also here. Mean for group data. Okay, I am sharing this in the descriptive box. Merits of arithmetic mean based on all observations is the main advantage suitable for further mathematical manipulation. It is a mathematical measure. These are the demerits of mean, median. Okay, divides the data into two parts. Median for grouped data, ungrouped data. Examples for median. Okay, we already discussed this formula also. This formula we have discussed in case of discrete frequency distribution. It is the value of the variable corresponding to n by 2 value. Here n by 2 is 30.5. 30.5 is here in the 42nd cumulative frequency. 14 is the median for discrete frequency distribution. Next one is, these are the merits and demerits, easy to understand. It should not at all affected by extreme values. It can be calculated for distribution with open-end classes also. These are the demerits. Not based on all observations. Should not be useful for further mathematical manipulations. It is the drawback. Mode. Okay, mean for grouped data, mode for grouped data, mode formula. F1 is the frequency of the model class, F0. Okay, some lecturers may use some notations. All are the same. Merits, demerits, geometric mean transformation, harmonic mean, merits, demerits. If zero values are there in the data, we cannot calculate geometric mean. It is suitable for finding averages of ratios, rates of percentages, etc. And harmonic mean for grouped frequency distribution, merits, demerits, rigidly defined, based on all observations, suitable for further mathematical treatment, easy to understand, difficult to calculate. If the data involves speed, distance, okay, that type of variables we can use harmonic mean. And these measures of dispersion, next characteristic, range, quartile deviation. Okay, calculation of Q3, Q4 here, mean deviation. Okay, this is absolute deviations, mean deviation, standard deviation. And next one is moments. We will discuss moments in detail later. This is skewness, lack of symmetry. Measures of skewness, Carl Pearson, Bowles coefficient, moments measure. These are the different skewness, positive, symmetrical, negative skewness, kurtosis, leptokurtic, mesokurtic, platykurtic curves. Okay, in this lecture, we have discussed different characteristics of frequency distribution, measures of central tendency, measures of dispersion, measures of skewness, measures of kurtosis. Thank you.